We got another theorem to toss out here. What have we learned so far? Okay, side, side, side. First one we learned in the last chapter, last section, side, angle, side. Then we just learned angle, side, angle, and now we're getting ready to do angle, angle, side. Now the key to this is if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So here's angle, angle, side. Angle, angle, side. Okay? So the side is not between the two angles, it's not included, it's attached to only one of the angles and not the other one, okay? So that's what we're trying to prove. Now example 3, as I was looking at your book, they did the flowchart proof, and some of you, I don't know if we do need to kind of review that. I don't know if you're feeling like you remember how to do this, but I'm going to walk you through it. We're going to use angle, angle, side to prove these triangles congruent here in this figure, okay? And I'll walk you through it. You can see what's given. Segment AB is parallel to ED, and segment BC is congruent to segment DC, and we're supposed to prove that triangle ABC is congruent to triangle EDC. Okay, so let's go ahead and get started with our flow chart. I like to go ahead. I don't suppose it really matters. This let's do a bubble right here. Okay, and we'll put in it that AB is parallel to ED, and we'll put underneath it that that's given. Now that's going to help us out in a couple of different ways, because those parallel lines are going to help us establish some angles that are equal, okay? So let's take a look at, let's see here, what we're looking for is we can't have included angles, so that are straddling these congruent segments here. So here's your congruent segments right here. So as you're planning it out and you're looking at it, you're going, okay, well, I can't really use these two angles right here. I guess I could and do angle A, angle C, and then the BC. I guess I could do that. You know, you can map it out and do vertical angles are equal. That's definitely a possibility. I'll show you what your book wrote down if you were kind of thinking that direction, because that's initially when I first saw the figure, that was the direction I was going to go to. So completely feel you on that one if that's what you were thinking. What we're going to do is we're going to create two branches. Okay, one of your branches is going to be, you're going to prove that in this bubble right here, that angle A is congruent to angle E. All right, now take a look at this. Why am I saying angle A and angle E are congruent? How am I saying it? Why am I saying that? Okay, look at your parallel lines. Pretend AE is your transversal. Okay, it's cutting across your two parallel lines. So what's true about those angles? They're in between, they're on the interior of the two outside segments, and they're on opposite sides of the transversal. So you could go, oh, that's alternate interior angles theorem. Okay? Now, because of those parallel lines, you can do it again. You can do it again with B and D. So why are angles B and D congruent? And again, that would be because of the alternate interior angles theorem. Okay? So there's your two sides right there, or your two angles. We use the same reasoning. I guess you could have put them in one bubble. I think you're supposed to do 2. And so the only other thing we have to include is, well, let's do the bubble for that one up top. It's that side, okay? And we were given that. We were told that BC is congruent to DC. We're not going to draw an arrow straight down because that information doesn't help you find the angle measures. But what it does is all 3 of these feed into this last bubble, because those are the 3 pieces we needed. We needed angle, angle, side to prove that triangle ABC is congruent to triangle EDC. And we can say that because of the angle, angle, side theorem. Okay, so there's your flow chart. Boy, that beats the heck out of doing a paragraph proof, doesn't it? A little bit less writing, more symbols, a little less writing. I don't know if you have a preference for the kinds of proofs that are out there, but flowchart's not too bad. I kind of like the statements and reasons, but the flowchart's pretty neat because you can line them up positionally, which is really cool too. All right, if you guys have any questions on that, let's mark it. Of course, that's not the only way to do a proof, but it's one way. It's how your book showed it, so that's why I showed it that way, just to kind of don't let you forget about flowchart proofs. And write down any questions you have.